A masonry dam of trapezoidal cross-section with one face vertical and a horizontal base is 7.2 meters high. It has a thickness of 0.6 meter at the top and 3.6 meters at the bottom. The weight of the masonry is 23.6 kilonewtons per cubic meter. What is the depth of water on the vertical side if the resultant pressure intersects the base at the downstream edge of the middle third or 0.6 meter from the middle of the base? So RY, the resultant crosses the extremity of the middle third near the toe. In other words, assume that there is no hydrostatic uplift. Then second part, that the uplift head varies uniformly from full hydrostatic head at the heel to zero at the toe. So let's have the figure first to analyze the situation. So this is the situation. RY should be intersecting the extremity of the middle third near the toe. So 3.6 divided by 3 is 1.2. So that's why this should be 1.2. Then we're looking for H such that RY intersects the base at that position. So FH, let's divide the masonry into this manner. So FH is acting H over 3 from the bottom because the water level is below the crest of the dam. So pressure diagram is triangular. So that's H over 3. FH, call that weight 1, weight 2. Then the distance would be 3.3. 3.6 minus half of 0.6.3, so 3.3. So 3.6 minus 0.6 is, this is 3. 2/3 of 3 is 2. So weight 2 is 2 meters from the toe. So FH is specific weight of water. Barred H is H over 2, area 1 by H. So 4.905 H square, that's FH. Then weight 1 is 23.6 times 0.6 times 7.2 times 1. Specific weight times volume. So 101.95 kilonewtons. Weight 2 is 23.6 times 0.5 of 3 times 7.2 times 1. So weight sub 2 is 254.88 kilonewtons. Therefore, Ry is just weight 1 plus weight sub 2. 101.95 plus 254.88. So R sub Y is 356.83 kilonewtons. Then having found Ry, we sum up moments about the toe equals 0. So Ry 356.83 times 1.2 plus FH 4.905 H squared times H over 3 then equals weight 1 101.95 times 3.3 plus weight sub 2 254.88 times 2. So only H is unknown here. 101.95 times 3.3 plus 254.88 times 2 minus 356.83 times 1.2 times 3 divided by 4.905. Then cube root of the result. H is 6.347 meters. Then in the second part, there is hydrostatic uplift from full hydrostatic head at the heel to 0 at the toe. So this is the uplift pressure diagram. 9.81 of H here because we do not know H. Then that's 3.6. So uplift is 0.5 of 3.6 times 9.81 H. Simplifying that uplift force is 17.658 H, and its moment arm from the toe is 2/3 of 3.6, so 2.4 meters from the toe. So Ry prime is 356.83 minus the uplift force. So 356.83 minus uplift force. Then we still have to sum up moment about the toe equals 0. 356.83 minus 17.658 H times 1.2 plus FH 101 4.905 H squared times H over 3 equals the same. Plus uplift rather. 17.658 H times 2.4 and equals the same. 101.95 times 3.3 plus 254.88 times 2. So simplifying, 4.905 over 3 is 1.6358 cubed. Then negative 17.658 times 1.2 plus 17.658 h times 2.4, that's 21.19 h. And 356.83 times 1.2 plus minus 101.95 times 3.3 minus 254.88 times 2 is negative 418. So by trial and error or by using your high-tech calculator, there is only one real root. The other roots are complex conjugates. So h is 5.669 meters. So that's the only requirement, the value of h